Hello, Mr. Malo here, your online math teacher. Welcome to my channel. Today we're going to be talking about using the law of cosines to solve for missing side lengths in triangles. So let's jump into it. So the goal is to be able to identify when we can use the law of cosines, but then we want to use it. So typically we're thinking of law of cosines, law of sines. These are non-right triangle problems, although these rules and laws do work for right triangle also. But the key giveaway is if you don't know an angle and its opposite side length, so you don't have a pairing, you're going to have no hope of using the law of sines in that situation. So you probably should go over and look to the law of cosines. So that's typically going to be when you're going to do that. So in terms of solving for side lengths, that's going to be precisely when you have an SAS triangle. So you won't have an angle and its opposite side length that you know, but you do have one angle and you do have two sides. So, and I have the law of cosines formulas here. The way I like to remember them is they're kind of like a slightly different version of the Pythagorean theorem. The Pythagorean theorem doesn't quite work. We don't have a notion of hypotenuse here. But if we tweak it just a little with this minus 2, say BC cosine of A, we can end up fixing up what we are off by with the Pythagorean theorem in a sense. So let's take a look at to see how we can use this formula to solve an actual problem. So let's jump into this example here. So in this triangle, you can see I know that side length A is 44, so I'll write that on my triangle. I see side length C is 23.4, so I'm going to write like 23.4 over here, and I have angle B is 80.2 degrees. So we can see very quickly we do not have an angle on its opposite side length. I know angle B, it's the only angle we know, and we don't have side length B. So I don't have that pairing. So that tells me I cannot use the law of sines. So I probably got to go over and use the law of cosines. Now, since I know angle B, that means that I need to use the version of the law of cosines that has angle B in it. So that version is B squared is equal to A squared plus C squared minus 2AC cosine of angle B. So notice it's kind of like the Pythagorean theorem, like I said, B squared is equal to A squared plus C squared, but I have to add that on that adjustment with this formula to get it to be correct. So let's plug our information in. We don't know B, so we just have B squared on the left. Now we have A is 44, so I have 44 squared. I know C is 23.4, so I have 23.4 squared. I have minus 2, 44, and 23.4. And now I have cosine of angle B is 80.2 degrees. Now, my goal is to solve for b, not b squared, so I can just take the square root of both sides to get rid of my squared. So that's going to leave me with b is equal to the square root of everything we just wrote down up there. So 44 squared plus 23.4 squared minus 2, 44, 23.4 cosine of 80.2 degrees. And at this point, all we need to do is plug this into our calculator to get that this is a 46.19. So that's approximately the length here. So now I have side length B. Now I would have to go find the angles. At this point, now that you have an angle and its opposite side length, because we'd have angle B and we just solve for side length B, you could go ahead and use your law of sines. Just make sure if you're going to solve for those angles, start by solving for the smaller of the two angles. So that's going to be angle C, because side length C is the shorter of the two sides here that are left after. And that's just to ensure you get this triangle, because if you remember back to the law of sines, there's that whole ambiguous case going on. So you just need to be careful to make sure you get this triangle that we started with here. So that's all there is to using the law of cosines to find side lengths. I hope you found this video helpful. Like and subscribe, and I'll see you in the next video.